All right, let's have a look here at some of that homework that we're going to have you do. Here's the first one. So we're going to do, I'm having you do some centroids, okay? So this is the first one. So when I'm doing these, I like to do these with tables. All right? So this is 341. So the technique on these, we're going back to centroids. This is the homework that'll be due with the final. Now, the final right now is scheduled Monday from 3 to 5, I think. Now, I know a lot of you have finals already on Monday, quite a few of them. So I also have and that'll be in this room, which is White Oak Hall. What is this, 212, I think? Anybody know? I'm pretty sure. Let's make sure we're writing it down. So that's White Oak Hall 212. Now, but if you want to, you could take it Tuesday, and that'll be 2:30 to 4:30. And that's actually over in the Forum 115. I have a final there with lots of room in it. So it sounded like a lot of you have a lot of finals on Monday. Forum, where is it? You know where the coffee shop is? Hot Shot Cafe, I think? It's around the corner from that. So next to the library kind of thing. It's a funny building. You got to go in from the south side. Okay. So here's the courtyard, and I'm pretty sure that's north. The Forum is kind of this conical thing, and you kind of go in this way. It's F115, first floor. There's some doors. It's kind of old school auditorium kind of place. Okay. So if you'd prefer, you could take it then too. I'm fine with that. All right. Either one. All right. So, and the library's right here, just to reference you. Okay, now the centroids, let's have a look at that. Now the approach on this, as we were talking about earlier, centroids are called out by the direction they're measured in. So X bar would be measured in the X direction, Y bar in the Y direction. Okay. So if I want to find the centroid for this shape, what I'm going to do, I'm going to use the axis system that's given. You have to have some sort of reference axes that you're measuring from. So I'm going to go with the X and Y, of course, and those are the axes I'm going to use. And then what I'm going to do is I'm going to measure from those axes to the centroids of the figures. I screwed up with X, sorry. Not doing too well today. Here we go, it's down there, it didn't look right. So X is here. So let's try that again, there we go. All right, now what I want to do then is figure out how far it is from those axes to the centroid, and I want to find the areas of each of the shapes. Now, as I've mentioned a number of times here, make it visual, okay? That way, if there's any errors going on, you'll see them, hopefully. There's about the centroid of the rectangle. Here's about the centroid of that triangle. And there's about the centroid of the other triangle. Okay? So I want to mark those off. And then what I want to do is measure from the y-axis in the x direction to those centroids. So I want these distances. Those are the x bars, okay? Then I also want the y distances. Those are the y bars, okay? Then what I do, I take the x bars times all the areas, add them up, and divide by the total area. That's it. That's my total x bar. take all the little y bars times their areas, add that up, and divide by the total area, and that's y bar. So that's how I would work through that. That's the approach. All right, so I want to get the areas. So that rectangle is 12 by 6. So that's 72. The triangle is 1/2 times 3 by 6. So that's 9. This other one, what is it? 1/2 times 12 times 15. So what do we got there? 150, 180, half of that, 90. Is that right? I think so. So there's the areas of the shapes. I want that. What I also want then are the x and y bar distances from the axes shown to the centroids of the shapes. Okay. So there are the x bar distances. So what I've got, oh, I guess I got all of them on there. So what I've got is for the x bar distances, I've got 6, which is half of the 12. That's how I get to the centroid of a rectangle. What I've got here is I would have 8, and that's 2/3 of 12. That would be 8. And then that top one, what do I got? The top one, I have to remember to add in the offset. I think this top one's going to be 13. That's going to be 12 plus 3/3, which is 13. Okay. So those are my centroidal distances. So the key to doing that is a rectangle. Of course, the centroid's in the middle, which would be half of the base from the, and half of the height from that corner, this being the total base and that being the total height. Okay. For a triangle, a right triangle, you go 1/3 of the distance from the right angle to the centroid, which means you go 2/3 of the distance from the acute vertices there to the centroid. Yeah, question there. Yes. Yeah, for that, this one, right. Yeah, that would be negative. So yeah, the y bar on that one would be a negative number because you're going down. I think that'll be -5, right? All right, now I just like to collect all that information. Then when I've got it, I'll just plug it in, okay? So for instance, for part number 1, it looks like I'm working on x bar here. I've got an area 72. I'm working on both of them, and I'm going over 6. So if I take 72 times 6, I get 4320. Okay. So I'm taking 72 times 6, and I'm getting 4320. I'm going to take the area of that little triangle there is 9. And I'll factor that up by its distance, and that will get me the x bar A term for that shape. All right, and then I'll do the same thing for the last piece there. So I'll just go through all 3 of those, and I'll just take x and y bar times A and get those figured out. So when I work through that, I'm going to get 4320, I'm going to get 117, and I'm going to get 720. So I'll just add them up, and I'll get 1269 there. That is the sum of x bar A. I'll divide that by the total area, which is 171. And that will get me 7.42 for x bar. I do the same thing for y bar. I'll take 72 times 3. That'll get me 216 for y bar. So I'm taking 72 times 3, and that's 216. I'll take 9 times 4, and I'll get 36. And then I'll have, I don't know, whatever that last one comes out to be. I think it's 5, negative 5 times whatever that is, 90. And I'll get negative 450. I add those up like that. I get negative 1980. And I divide it by the total area, 171. And I'll get negative 1.16. Okay. Got any questions on that one? What's that now?
You have 1980, but it's negative 198.
Oh, it is 198. Yeah, thanks. There we go. Okay. So that's the approach on these. And then we've got, that's that one. That's the most straightforward of the two. It's just made out of rectangles and triangles. We've got another one that's made out of more complex shapes. This is similar to what we did in class. So what I'm seeing there are some cutouts. Triangular cutout there. Semicircle there. Triangle here. So break it up into pieces. Show where the centroids are on the pieces. And then just put everything together is how I would approach that. Okay.
So would you treat the center square and then you would just subtract the values of the triangle from it?
Yes.
So it cut out.
Yeah. So we got we've got a triangular cutout, a rectangle, a semicircle, and another triangle. So there are the areas. The area of what I'm calling number 1, which is that triangular cutout, that gets a negative sign. That's negative 144. The area of the rectangle, the large rectangle in the middle, is 2376. And the area of the semicircle is 226.2. I've also got the triangle attached to the right-hand side, 18 by 36. We could figure that out. Come up with that area as well. Okay. So you start with those areas. Those would be centimeters squared. Okay, now you want to find the centroidal distances to each of them. So I've got the y bar distances in purple and the x bar distances in green. Okay. And again, I like a sketch because that way if I'm busting a number, if I'm making a mistake, I can look at it and I'll see it, you know. Do we have any questions on that so far? Those distances? Okay. So then I'll start to fill that in. Okay, I always want to have a table for these, especially these more complicated ones. Okay, so that triangular cutout has an area of negative 144. The x-bar distance will be from the y-axis to the centroid. Okay, the length of that triangle is 2 times 12, it's 24. So I'm going to go from the y-axis to that centroid of that, okay? That's going to be a positive 4. You do have to watch your signs on this. So we're going to go positive 4. And then y-bar will be 14. Okay, I'll post keys for this because I'm not going to be able to grade this before I get it back to you. And we will have this on the final, so I'll get a key up for this if you like, where you could have a look at it.
Is the final cumulative or just?
No, it's not cumulative.
Okay, good for us.
Well, let's see. Hang on, I have to quantify it. It covers the material that we've had since the final. It will have some aspects on it that are cumulative, but they're very specific. So it's not like wide open cumulative. Right?
Okay.
So there'll be a 3D problem on there, which will be, there'll be a 2D equilibrium problem, like what you had on the midterm, a truss, method of joints. And I'll get you a list of this. Why don't we finish this up and I'll get you a list after that. Okay, why don't we do that? So we doing okay on that so far? So we good on this one, how we're doing this? It's the same process as the previous one. This one has a little bit more of a complex shape, plus it has some negatives in it that we have to pay attention to. Okay, we good? I'll post keys for this if you want to have a look at them. All right. Tell you what. So let's have a look here. Now I give you that list. There's more stuff on the list than will be on the final. We didn't get all the way through. So let's see what we got. Yeah, that current. So the first thing are frames and machines, so there'll definitely be a frame and machine thing on there. What you do, you break things up into pieces, and then you work your way through from what you know to what you don't. Look for two-force members, but don't assume there are any in there. Some frames and machines do not have them. Remember to turn the forces around as you work your way from one member to the next. That's important.
So when you have a two-force member, that means that on each of the joints, there's just opposite, like you just the opposite.
And they point towards each other from one joint to the other, and they're opposite, yeah. All right, now the next thing here is centroids. Now I listed both algebra and calculus, but we didn't really cover the calculus, so that will be out, okay? But we'll do algebra centroids similar to what we just did just a minute ago in class, okay? So there'll be algebra. I would get yourself a table. Just be sure you can set up a table and fill it in, all right? All right, moments of inertia, same thing. We'll go over that on Friday. I'll assign you a couple problems, but I won't give you any calculus ones. They'll be algebra based, all right, like what we did in class. So algebra based, so you want to set up a table, one for I bar x or I bar y, and then the other for a, d, and then you add the AD squared term for moment of inertia. Okay. Product of inertia, we did not get to. We kind of ran out of time this year, unfortunately. Okay, we were also supposed to do shear and moment, but we didn't do too well on that either. We didn't get to it. So that shear and moment will be gone also, okay? So what we've done here, basically, from the midterm, that'll definitely be on the final, frames and machines, algebra centroids, and then moment of inertia, algebra style, okay? That's what'll definitely be on there because we covered that since midterm 2. So we good with that? Now the stuff from before that will be on there will be some 3D stuff. So this is on the second page I gave you. So there'll be some 3D vectors on that. There'll definitely be a position vector, unit vector, force vector thing. You know, remember that? Now I know that, what's that? Yes, yeah. Now it won't be anything really tricky. It's just I just want to be sure you can run through 3D vector stuff. So I'll have you for sure do a 3D force vector. And then I might have you do a projection with it. I might have you do a moment with it. Or I might have you do a resultant. Okay, projections are a dot product, F dot UR. Moments are a cross product, R crossed F. And resultants are adding vectors together by component, X, Y, and Z components. Okay? So look at that first midterm. It's very kind of cookbook. I mean, there's a few steps, but just be sure you can walk through the steps. I want to encourage you to look at that stuff because that was a couple months ago, and you know, you want to be sure that you look it over. You might probably need a little brush up on that. Maybe we'll go over that on Friday if you like. Okay, there'll also be a 2D equilibrium problem using trig. I think it was like number 2 on your midterm, something like that, because I want to be sure we can do that. And there'll also be a truss, just method of joints, so I won't do sections. I'll just give you a basic truss and have you work through it. Okay? All right, so one more time, probably what we're looking at on this thing is a frame and machine, which those are the trickiest ones often. A centroid with algebra, moment of inertia with algebra, those are process problems. Get the table set up, fill in the table, you know, approach it that way. A 3D problem of some type, nothing, you know, really intentionally tricky or anything, but, you know, a moment or a projection or a resultant where you build vectors and do that, all right? And then a 2D equilibrium problem with a bit of trig in it, like what you had for number 2 on your midterm. And then a method of joints problem. Okay. So there you go. We can go over that a little bit on Friday. I don't know if you have any questions now. I'm happy to take them. We've got a couple minutes, but you're okay with that. I've got.
Could you go over the method? Well, I don't know how long it would take. Could you go over the method of joints problem on the midterm?
Midterm method. Yeah, I mean, we could probably knock through that pretty quick if I can find it. The main challenge won't be going through it. The main challenge will be finding it. Yeah, I figured that was it. So we hit that, and that pops up. There we go. I think we got it. Okay. There it is. Now I've got this posted in Moodle, you know, and we've done a number of these things. Okay, when you're doing a truss problem, you want to do 2 things first. The first 2 things you want to do is find the angles of any of the members that you want to solve for. So I know I got to solve CE, so I've got a rise of 6, a run of 4. Arctangent will get me the angle, 56.31 degrees. I also, generally speaking, want to find reactions. So I'm just going to treat that truss as one whole object. I'll outline it in purple, I guess, so something like that. And I'm going to take a moment about A and find the reaction at B. It's 1200, or excuse me, reaction at E, 1200. Now on this one, all the members I wanted to find were right over there, so that's the only reaction I bothered to find. Now you could find this one easy enough. It's just 600 by going sum of Fy. But you want to find the reactions next. So you want to find the angles of the members and the reactions before you do anything, generally speaking. Okay, now what you're going to do after that is you're going to start on a joint that has a known force and no more than two unknowns. Okay? And that was something that was a problem on the midterm, because I had a number of people go up here to C. And as you say when you're guarding someone in basketball, that ain't happening, man. Okay. All right? Okay. So there you go. You've got three joints coming in there. They're three members. That's one too many. You just can't do that. All right? All right. So you've got to start at joint E. You have to, because there's only two unknowns. See, the reason for that is you've got two dimensions only to work with, some of fx and some of fy. That's two equations. You can only solve two unknowns. That's all you can do. So you go to joint E, all right? So we go to joint E and we draw a picture there like that. Okay, and we got 1200 up, and we got CE coming. I'm just going to assume it's down, which is probably a good assumption because 1200's up. Something's got to be down to hold that thing in equilibrium. And then if CE is down, it also goes to the right. So DE has to go to the left to hold equilibrium. That's kind of what I think about there. Now, if I don't get those directions right, that's okay. I'll just get negative answers. It's no big deal. Okay. And then I just do force equilibrium equations. Okay, 1200 up. Now I'm going to start with y because I only have one y unknown. That's why I'm starting with that. So I'll get 1200 up, and then I'll get sine of 56.3 times FCE down. And I know those two balance out. The sum of those is 0. Okay. Then I solve for FCE. It's 1442 pounds compression, because the sine of 1442, the sine of 56.3 times that is 1200. That's what it balances out, you know. All right. Now, once I've got the 1442, I can go sum of fx, set that equal to 0. I've got 1442, which I just found, times the cosine, which would be the adjacent to the angle. So that's going to the right there. That's the component of CE going to the right. And then I go minus FDE because it's going to the left. And I solve for FDE, it's 800. Okay. So what I found is CE is pushing down and to the right, so it's in compression. DE is pulling to the left, so it's in tension. Okay. Now I want to go up there to joint. So we good with that? We got any questions on that? Okay, so now I know that CE is in compression. Think of taking like a block of rubber and pushing on it with your hands. It pushes back on both of your hands. So what CE does is it turns around. It's pushing on C also. So it was down right on E. It's up left on C because it's in compression. It's pushing outward is what it's doing. Then I want to get CD, so I do a sum of Fy equation. CD up, positive. Sine of 56.3 times 1442 up, that's positive, and then minus 1800 down because it's negative. So I just, those things are in balance. The sum of those is 0, just the y components. So you just work that out. You can solve for the one unknown, which is CD. It works out to be 600 compression. Let's see. The main problems I saw, you know, people were starting at C, and again, you just can't do that. You got too many unknowns. It just isn't going to work. For some reason, people are assuming that DE was 0, and I didn't quite understand that, but that's what they were assuming. They were looking at the reaction at E, which is 0, but there is a component of force in there from CE. And then some people were mixing up their X's and Y's. They were putting both X and Y in the same equation. And you don't do that. It's all an X equation and a Y equation. Okay. So those are the things that came up on that. I don't know if there's any questions on that. All right.
Is this about the size of the section problem that we'll have on file?
Method of joints, yeah.
Method of joints, sorry.
Yeah, I probably, you know, if I have you work through a whole truss, it'll be a small truss. I won't have you work through some huge truss. There's no reason for that.
The last question on the midterm.
No, I won't, that had to be done with sections.
Yeah, that was a big one, okay.
Well, yeah, and actually, it wasn't, there was a lot of
When you
stuff on
showed us
it.
how to do it, it was a lot easier.
Yeah, well, I guess it's always that way, and then, but,
Make it look easy.
yeah, I won't put anything like that on there, that's not my intent. I just wanna make sure you can do a truss, is what I want to know. All right, so, Friday, I think I'll go through a 3D review problem on Friday. We'll do a couple moment of inertia ones. I'll show you how to do those. I'll post the keys for the centroids and moment of inertia. Now, I'll give you a couple of moment of inertia problems to work on. You can turn these in with the final, because this could be on, probably it will be on the final. So let's get you a couple of these to do. How about 361 and 362? Okay, so these problems, I said they were due Monday earlier. Why don't I just make it Tuesday? Because some of you, I imagine, will take the final on Tuesday. So all of these will be due Tuesday now. And that will be the 17th, I think, which I think is St. Patrick's Day. And then, what else do we got? 341 and 2 also. So all those are due on Tuesday now, okay? So 341, 342, 361, and 362, and those are due on Tuesday. All right, good to go.